Hi, Jim Eisen here, Chief Sales and Marketing Officer from One Stop Systems. Going to do a walkthrough of the 4U Pro, which is our premier expansion system in Gen 3, Gen 4, and soon to be Gen 5 PCI Express. So what is the 4U Pro? It is a semi-rugged expansion system. An expansion system uses something like this, your host card. This is our Gen 4 host card that goes into a host server. The host servers we recommend are the OSS 2U EOS server. EOS stands for Expansion Optimized Server. And we also have our 3U SDS short depth rugged server, good for edge applications. We'll do videos on those to come. But basically this card will go in any server, short card depth, half height. And then it expands using the PCI Express cabling standard from the host card, using up to 4 of these, and plugs into the back of the 4U Pro. And what this does, it gives you up to 16 to 17 additional slots off of your PCI Express server. So we're going to do a quick walkthrough of all the features of the product. So to get inside the chassis, 2 screw holes that basically just need Phillips screwdriver, and slide the chassis cover back, and we look at what's inside. So the major components of the 4U Pro consist of the main backplanes. So in this case we have 2 different backplanes in there. Our all by 16 Gen 4 backplane that can do have up to 4 double wide cards in it. Or we have a and also we have a backplane that has 8 by 8 slots, just to show the 2 different configurations that could be here. So you have your main expansion backplanes. Each of them has a target PCI Express expansion card. The power supply area of the backplane. So there's 2 power supplies in here that are load sharing redundant supplies. We'll talk more about those in a little bit, in both AC and DC inputs. The power supply backplane and power distribution board. That's a very important board. It has the optional IPMI system monitor and all the power distribution for things like the expansion cards, fans, and things like that. At the front of the chassis is the fan intakes. 3 120 millimeter fans that grab the air from the front and send it to the back. All these fans are removable. So I'll show you that real quick. And hot swappable. This could be done while the chassis is running. Everything is finger protected. And also the fans have an optional filter. So the fan filter can also be removed when maintenance is needed. So the filter comes in and out. If you don't need a filter for your application, we can also sell it without the filter. But fairly easy in and out. And it does screw down, so everything is secure and made for rugged environments. You also notice that there is a double wall on the chassis. There's a frame-in-frame design that helps with the ruggedness of this chassis, which is made of steel. So we can install GPUs into the chassis. These are double-wide GPUs like the NVIDIA A100s. And as we know, these need extra power, so the power cables can be routed from the GPU to the power backplane. And we buy these from One Stop Systems, complete. They come already nicely routed and cable tied into the chassis. This is not only for GPUs. We can also put FPGA boards in here for data acquisition, networking boards if you need a lot more networking, like NVIDIA Mellanox cards. Those can all be put in here as well. So as you see on the GPU side, we can fit up to 8 GPUs, 4 on each backplane. For standard single width cards, we can fit up to 16 of those in here. But there's additional features. One of the features is the IPMI system monitor that has an Ethernet connection either out the front of the chassis or out the back. But in addition, we can add up to 2 more slots above these slots using the expansion tray. And we'll show you how to set those up in a minute. So now we're going to focus on the backplanes and the different configurations that can be ordered from the factory. This backplane here, otherwise known as the 538 backplane, that is the Gen4 bi-16, all bi-16 slot backplane. If it comes like you see it here with no cables connected, then you have a target card that's running the PCI Express from the server down into the switch, and these first 4 slots are activated at bi-16, which is fine. You don't need that 5th slot if you're using 4 GPUs because it'll cover that last slot. So if your backplane comes with the 2 ARC6 cables connected into these connectors, then all 5 slots of bi-16 are activated. And that's good if you only need 2 or 3 double wide cards and have a few single wide cards, something like your FPGA inputs or networking cards that go in that slot. And the 3rd configuration has the ARC cables from the back going up to the optional tray, which effectively moves the bi-16 slot from the last spot on the backplane up to this tray. That is good if you wanted 2 host cards per backplane, because you can put a host card up here, or if you had 4 GPUs down the bottom, you could add a networking card like this into this top slot, so take advantage of the extra 1 U of space. And the last potential cable configuration is the actual 2 backplanes can be connected together, and in that case this host card is not needed in the chassis, and 1 host card and 1 target card can run all of the slots in the expansion system if you only had 1 slot in your server and needed all this expansion. So overall, it's a very flexible configuration platform. And next we'll move on to the power supplies. Now we're looking at the back of the chassis where we have the 16 expansion slots, 1 target card in this configuration that has the PCI Express cables that go back to the host, and 2 redundant load sharing power supplies. What we're showing here is a 110 AC input supply that can go up to 2,000 to 2,500 watts, and a DC input supply that takes 48 volt DC, good for say autonomous applications because this is a rugged environment. And pretty easy to remove. This CRPS power supplies, pretty small, pretty dense, and if you wanted to go even higher wattage, say if this is full of GPUs, they can be interchanged with this one. See, it's a 220, 240 volt input power supply that is all the way up to 3,000 watts each. So this supports 6,000 watts of power total or 3,000 watts redundant. You also see we have an IPMI system monitor Ethernet input, so you can control and monitor everything in the chassis. In addition to the 2 power supply configuration, if you wanted to have a single power supply to save some weight or don't need as much power, there is a filler panel available that can be inserted into this location. So this chassis is currently in a 2-host configuration, and with that you can use an optional hold down bar. This is just a sample one, but you can see the holes here for the hold down bar, and we use different heights of foam to be able to compress onto the say cards like GPUs or FPGAs, and this can be moved into which locations are going to be least interference with anything that might be on the board. In addition, if you go to 4-host configuration where you use the ARC cables to go up to the tray like that, the bottom of the tray actually is the hold down bar, and you use the same foam type application to hold down the cards. That way the cards are held on 3 sides, helps in shock and vibration for the rugged environments this chassis can go into. And finally, to the front of the chassis, where you see another IPMI Ethernet input if you wanted to do the monitoring and control from the front instead of the back. A couple of LEDs, an IPMI LED that shows the status of the monitor, and a standby power. In addition, the logo up here has a purpose that shows power good when the power system is on with a nice bright blue LED. The Gen 4 PCI Express version of the 4U Pro and EB4400 products, as well as many other Gen 3 PCI Express OSS expansion products and servers, come equipped with an IPMI 2.0 compliant baseboard management controller, or BMC, that monitors and controls the system. There are 3 modes of accessing and utilizing the BMC, depending on the level of monitoring and control desired. First, there's a simple system, status, and information screen accessible via a web browser that provides health status in an easy-to-understand display. Second, there is a command line interface with a rich set of commands that provides both monitoring status and remote control of various parameters in the system. And third, there is a full-featured API for integration of the system into larger IPMI-compliant customized monitoring and control systems that you might have in your facility. For purposes of this training video, we will show examples of the health status display and command line interface. A programming guide is available with all the available commands, as well as instructions for implementing the API into custom systems. To access the BMC in the IPMI-equipped OSS system, connect the system to the management network via the marked BMC RJ45 connectors on the front or rear of the system. Once connected, you can search for the IPMI or MAC address of the BMC. The MAC address may be found on a sticker near the port on most OSS systems, or you can manually search for the IPMI and MAC using a tool such as Advanced IP Scanner shown here. After fully scanning the network for available IP and MAC addresses, you can search for the OSS BMC MAC address, which always starts with a 00:18. In this example, we find 2 OSS BMCs on the network. Since the OSS products can scale from 1 to hundreds of systems in various server expansion and composable infrastructure architectures, you may find more on your management network. In this case, we're interested in the BMC connected to the IP address ending in 146. So we copy this IP address and switch over to a web browser where we can paste this address into the search bar. This brings up the monitoring screen, which will show various live parameters, including system and component temperatures, fan speeds, and power supply voltages, which you can see update about every second. Your screen may be different depending on the system configuration, number of backplanes, power supplies, or fans in the system. In this case, there's 1 backplane installed with 2 temperature readings, one near the air inlet and one closer to the air exhaust of the system, so you can get an idea of the instantaneous temperature profile of the system. Now, for more advanced monitoring and control of system resources, such as setting the IPMI BMC security policy, adjusting fan speeds or automatic fan speed profiles, remote system reset or on-off functions, things like that, a command line interface is available. Since we know the IP address of the BMC, we can use a tool such as PuTTY, shown in the demo, to access the BMC command line. For first-time login, the security policy is not yet set, so you can enter the BMC using username root and simply hitting enter for the password. It is highly recommended that you consult the programming guide to set up the BMC security login and password according to your company's security policy. A list of popular commands is provided upon entering the CLI, and you can issue the ls command to see a larger list of available commands at this level of the directory. To control a parameter such as fan speeds, the command fan_ADM1026 will provide instructions on how to set up your CLI command. For something like remotely turning the system on and off, the command PWR_ADM1026 will provide a similar set of instructions for issuing power on and off commands. Since the BMC runs on standby power, As long as the OSS system is connected to a live power source, the BMC remains operational to provide status and accept commands through the CLI or browser. There are many more commands available, and please consult the guide. And for more advanced CLI or API implementations of the one-stop system's IPMI BMC, you can also consult the programming guide.